Hello. In this video, we will determine if two triangles are congruent by using the side-side postulate, or SSS, and the side-angle-side postulate, or also known as SAS. Okay, so yeah, we can now prove two triangles are congruent by using these two theorems, SSS and SAS. So let's talk about the side-angle-side postulate, SAS. If two sides and the included angle of the one triangle are congruent, then the two sides and the included angle of the second triangle, then the two angles are congruent. So if you look at this two triangles, triangle ACB is congruent to triangle DFC, and I'm missing an F right here. D DFC, ACB, DF. So this should be DF, and then this should be a C. Okay, by side angle side. So you have to have a side, and then the angle has, this is also very important. The angle has to be between the two sides. If the angle is not between the two sides, then you can no longer use SAS postulate. Okay, and it has to be in that specific order. You have to have a side, and this has to be a side, and the angle has to be between the two sides, and then the two side lengths, right? To show that two triangles are congruent, you need three pairs of corresponding parts. Right, so it just means the three side lengths has to be the same. And then let's talk about the side postulate. This one's a little bit more easier. If the three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. As you can see, you have three sides. There's no angles. We don't care about angles. We only care about three side lengths. If you have three side lengths, then you can use SSS postulate. So you could say triangle ABC is congruent to triangle XYZ because of the SSS postulate. So let's look at example one. Example one says, are the triangles congruent by SAS postulate? So yeah, you have these two triangles. Is it congruent? Are these two triangles congruent by SAS? So SAS, side, angle, side. So let's look at this triangle. You have a side, and then the angle is 70 degrees, and then the other side is length ST. Yes, that would work, right? Because the angle is between the two side lengths. And then let's look at the other triangle. Your side length is line segment AB. Your angle is angle A. And then this should also been two marks here. And then, yeah. So yes, this would also be SAS because the angle is between the two side lengths. So you could say yes by SAS postulate. And then you have to say the triangle. So you could say, in this triangle, you could say triangle STQ. So STQ. Now you don't have to say STQ. You could also use QST, but as long as it's the same order as the other one. So yeah, STQ is congruent to triangle. So STQ. How would you say the other triangle in this order? ACB. Okay. So yeah, the angle must be between the two adjacent sides. Very important. Okay, example two. Here we have two triangles. So are they congruent by the SAS postulate? So here's a side, an angle, a side. That would work, right? Because the angle is between the two side lengths. Yes. What about this triangle? You have a side, an angle, and two sides. Yes, because the angle is between the two sides, so check mark. So you could say yes by SAS, and then you could say triangle TVR is congruent to triangle ABC. Okay, let's move on to example 3. So are these two triangles congruent by the SAS side angle side postulate? Uh, let's look at this triangle. So here, let's look at this triangle. We have a side, but we have a problem. Do you see the angle? It's not between these two sides, right? So it wouldn't work, but it would work if if the congruent angle was angle F, because angle F is between the two side lengths, right? This will not work. So it doesn't matter. Both have to be the same. Both has to work. This one, yes, as you can see, the angle is not between the two side lengths, so you're going to say no. And then I guess you could say the angle is not between two sides. Move on to example 4. Are the triangles congruent by the SSS postulate? So this on this two sides. This one, if you look at this triangle, it doesn't matter where the sides are as long as there's three sides. You have one, two, three. So this would work. And then over here, one, two, three. So yes. So you could say yes, or you could say triangle ACB is congruent to triangle PRQ. Okay. Okay. Example 5. So we have these two triangles. Is it SSS postulate? Uh, if you look at, we have two triangles. You say this one and then this one. Now, this side length should be congruent because of reflexive property. But be careful. On this triangle, there's one, two, three. And then in this triangle, yeah, see, this is a bit off. Yeah, this wouldn't work because look at the check marks. You have 3 marks here, and then we have, wait, actually, I should have, we can't conclude. Let's pretend this wasn't true. Let's say that this side length is not congruent with this side length, the reflexive property, right? So you have 2 check marks here, and then where's the other one? So that makes it false. And then just looking at this side length and this side length, they kind of have to be the same because yeah, this wouldn't work because this has only 2 check marks. This has 3. Uh, if we said this was the third one, this side length is not congruent with this side length. That's for sure, right? Let's say this is a third. For this triangle, let's say this was the reflexive property, and then this is you would have 3 check marks. This 3 check marks does not match up with this 3 check marks. This has only 1 mark, and then this has 2. So that means they're not congruent. So no, not congruent. That was a tricky one. Let's look at example 6. We have this. parallelogram, which could breaks it into two different triangles. So are these two triangles congruent by SSS postulate? So let's break it into, look at this triangle one. You have this check mark, you have these two check marks, and then you have these three check marks, right? So that would be SSS. What about this one? You have one check mark here, two, and then this one. Yeah, this lines up with this one. This lines up with this one. And then this three, this is practically the same thing as this one. So yes, SSS postulate. And you can say triangle ZWY. ZWY is congruent to triangle XYW. Let's move on. Example 7 says write SSS or SAS or not congruent. So yeah, it might be SAS. So let's look at this triangle here. You have a side, an angle, and then the third side is this. So the angle is between the two sides. So this would be yes. Now, if you look at this triangle here, we have a side, the angle, and then these three marks. Yeah, because the angle is between these two side lengths, so I'm going to say yes. So I'm going to say yes. I S A S postulate, and then you could say triangle Q W U is congruent to triangle U S Q. What about these ones? This one? Uh, it looks like you might, so they want to know if these two triangles are congruent by either SAS or SSS postulate. I think it would be SSS postulate. If you break it into, there should be two triangles. If you break it into two triangles, this one right here, and then if you use this triangle right here, it would be now this one has a check mark here and a check mark here. This creates two check marks, so it would be two doubles. So this one would be yes because this is definitely SSS, and then this is also SSS. So I'm going to say yes by SSS postulate, and then you could say triangle JGH, JGH is congruent to triangle LHK. Okay, let's look at number 9. Um, are these two triangles are congruent by SAS or SSS? So you have this straight line. That means this side is congruent with this one. So you'll have the third check mark because of the reflexive property. So I think this would be SSS for this one because you have a side, a double side, two check marks, and then a third one. So you have three different sides that are congruent. And then the same with this side, two check marks, and then three. So that's SSS. I'm going to say yes by SSS postulate. And then you could say triangle WZY is congruent to triangle WXY. Number 10, uh, is this side, 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 or SAS? I know it's not side, side, side because they don't have all three sides, but we have an angle. Now, is this angle between the two side lengths? No. It would have worked if it was here, right? If the angle was angle G, because the angles that would be make it two between the two side lengths, but no. So this is going to be no. This angle is not between the two side lengths. Okay, what about 11? Um, is it SSS or SAS or even neither? Yeah, I don't think it's SSS either because if you look at this triangle, there's no third there's no third check marks to represent a third congruent side length, right? These you have a one and then two check marks. That's it. Mm. And then it's not SAS because there's no angle that's congruent. These two angles are not congruent. They are not congruent because they look like vertical angles, but they're not. So that we have no congruent angles, so it's going to be no. Not congruent. Okay. 12. Are these two triangles congruent by either SAS, SSS, or SAS? Uh, I don't think it's SSS because there's no third check marks, or there's no two check marks to represent a second. You have one check mark and then this reflexive property. You only have two side lengths, no third side. Now, is it side angle side? You have a side, here's the angle, and then the third side is right here. So is the angle between the two side lengths? Yes. And then if you look at the same second triangle, you have a side, the angle, and then this side. The angle is definitely between the two sides, so yes. So you could say yes, SAS postulate, and then you could say triangle AED is congruent to triangle CED. Okay, let's do a proof. So complete the two-column proof. We are given that line segment PQ bisects line segment RS at M, and line segment RS bisects line segment PQ at M. Prove that triangle PMS is congruent to triangle QMR. So we're trying to prove that two congruent triangles, two triangles are congruent by either SAS or SSS postulate, right? So our last statement will either be uh, SSS postulate or SAS. So yeah, what do you think? You have these aside. So if you see that there's two triangles, this one and then this one. You have a side and then this other side length. Do you have any angles? I believe so. This angle, see how they make that crisscross, they are vertical. So this angle is congruent with this angle because of vertical angles. So it's most likely going to be side angle side postulate because you have a side and the angle and then the side. The angle is between the two sides, so yes, SAS postulate. Okay, so let's see how we do this two comp proofs. So what I do is always write out your given. So what are we given? Two things. Line segment PQ bisects line segment RS at M, and then line segment RS bisects line segment PQ at M. So let's write out our two given statement. Okay, statement two. What would be another reason? So we're saying that it's side angle side. Could we also say that M is the midpoint of PQ? So here is PQ, M is the halfway point or the midpoint, and then M is also the midpoint of RS. Yeah, we can say that. So we could say M is the midpoint of line segment PQ, and then M is the midpoint of line segment RS. And that would be the definition of a segment bisector. Okay, what else can we say? So we need a side. So we could say that line segment PM is congruent to line segment MQ. Yes, right? You have these two check marks. That means they are the same. Congruent, that means they're equal to the same. Line segment PM is congruent to line segment MQ. You could have also said line segment SM is congruent to line segment MR. See how they have one tick mark? That means they are the same congruence. The reason why they're congruent is because of definition of midpoint. And then I think we need an angle. If we're going to use SAS, we're going to need two angles, right? The fourth statement, you could say angle PMS. PMS, so this angle, this vertical angle is congruent to angle QMR, this angle. And why is vertical angles are congruent. Okay. And then the last statement, it's like the final wrap one. Uh, you could say that these two triangles are congruent by the SAS postulate. So you could say triangle PMS is congruent to triangle QMR. And the reason is SAS postulate. Okay, that wraps it up for SSS and SAS postulate. The next video would be proving two triangles are congruent by ASA, angle side angle postulate, and angle angle side postulate. Okay, I'm going to stop here.